And now on to Mars. So as people were first considering Mars, they figured it's got a similar tilt to the Earth. It has a similar length of day for the Earth. Maybe these are the things that are necessary for Mars to actually have life. So maybe Mars has life. Well, some astronomers actually suggested that they saw seasonal vegetation changes. So remember, during spring and summer, plants grow and bloom, become very green. Then during fall and winter, they die out and turn brown and gray. There were some astronomers who actually claimed to see this, that in spring they saw regions turning green, and then in fall they would turn back to brown and gray. In fact, there was one astronomer by the name of Lowell who thought he saw canals on the surface of Mars. So this would suggest not just life, but intelligent life on Mars. He actually suggested that maybe the Martians lived clustered around the equator, and they were actually harvesting water from their poles and sending it along the canals towards the equator where their cities were. Well, using more updated telescopes, we can say for certain there are no canals on Mars. What Lowell saw were actually a bunch of craters. Now, because of the way that the eye and brain work, it's very easy with low resolution for these things to appear like they're actually connected together. So no, there are not canals. The seasonal vegetation changes are again an optical illusion. So what happens is anytime you have a red region next to a dark area, the dark region appears greener. This is just a weird trick of the eye. It's actually been known for quite some time. So no, there is no vegetation. There are no aliens on Mars. It appears to be a dead desert planet. So it's actually very cold and wind blown. There's enough wind on Mars that it can actually create global dust storms. So here we see in June of 2001, we can easily see down to the surface, actually see surface features, but by September, there's a global dust storm and we can no longer see any of the surface features. As we look at the topography of Mars, we see that there are northern lowlands and southern highlands. We also have this region known as the Tharsis Rise that is much taller on average than anywhere else on the surface of Mars. So Mars does appear to have no active tectonics today, although it appears to have evidence of tectonics, some sort of tectonics at some point in the past. Now again, not plate tectonics. The Earth is the only planet to have had plate tectonics. Instead, we think that the Tharsis Rise, this region here that is much taller on average, was formed through a mantle plume. The mantle pushed up against the crust, causing it to bulge out in that region. Well, as this happened, it may have caused enough stress on the surface to then cause a giant crack, creating the canyon Valles Marineris. Valles Marineris covers about one-third of the length of the surface of Mars, and if it was on the Earth, it would actually stretch from LA to New York. It would actually span the entire continental US. So we get excited about the Grand Canyon, calling it grand. It's got nothing on Valles Marineris. We do see there are volcanic features on Mars, although we've never actually seen an active eruption. Mars actually has the largest volcano. Olympus Mons is the largest volcano in the entire solar system. To give you a sense of scale, Olympus Mons right here is actually the size of the entire state of Utah. So it is really, really big. Now again, although we see volcanoes and volcanic rock, we don't actually see any evidence of active volcanism today. We do see some lava flows that appear to be a couple of million years old, but that is the most recent. Now, unfortunately, that doesn't actually tell us if Mars is now volcanically dead Or is it just really slow? This is actually an ongoing question. Does it have eruptions every few million years, or is it just done? We have various probes that are actually trying to look into this. Currently, there's the Mars InSight lander that's trying to kind of figure out more about the geology of Mars. Hopefully, we'll be getting some good data from that soon. What we see in this image, these kind of look like volcanic plumes. They're not. These are actually clouds. So as the atmosphere gets pushed up over these volcanoes, it gets pushed up so high that we actually start to form crystal ice clouds in the upper atmosphere. So Mars does have an atmosphere, although it is very thin compared to the Earth's. It's just about 0.6% of the Earth's atmosphere. So Venus's atmosphere is about 100 times larger. Mars's atmosphere is about 100 times thinner than the Earth's. Now, it is, again, predominantly carbon dioxide, 95-ish, 96-ish% carbon dioxide, with most of the rest being nitrogen, again, similar to what we see on Venus. However, we do see a slight component of water vapor on Mars, which actually leads to clouds of ice crystals. So there are water ice clouds on Mars, and then in the really high upper atmosphere, like what we saw on those volcanoes, there's even carbon dioxide ice clouds. As we've studied Mars, and specifically looking at the poles, we've actually seen the polar ice caps grow and shrink with the seasons. So during fall and winter, the planet is going to be tipped away from the sun, the pole is going to be tipped away from the sun, which means it's going to get very, very cold. It actually becomes so cold that carbon dioxide freezes out of the air, causing the ice cap to grow. Carbon dioxide is the same thing as dry ice. If you've ever played with dry ice, it's really cold stuff, and that is freezing out of the air. Now, during spring and summer, the pole gets tipped towards the sun, receives more sunlight, and heats up. So that carbon dioxide ice then sublimates, goes from being a solid back into being a gas, leaving behind a much smaller ice cap. The ice cap that remains through summer is actually made of water ice. So we do know that there is some frozen water on Mars. Now, many landers have actually made it to Mars successfully, and they have shown that the surface is covered in a very fine powdery soil. This is Martian regolith. And the winds on Mars are actually sufficient to create dunes, these dust dunes. From orbiting spacecraft, we've also seen dust devils. So just like we get dust devils on the Earth, dust devils can form on Mars. So again, we're kind of left with the question of, so what happened? Venus, Earth, and Mars all should have started in the same way, so how is it that they've ended up so different? We've already talked about how Venus ended up with a much stronger greenhouse effect because of boiling oceans and volcanic outgassing leading to more carbon dioxide. The Earth had liquid water for extended periods, which helped trap away carbon dioxide, decreasing the overall greenhouse effect, and then later it produced life, which has significantly processed and changed the atmosphere. Mars, on the other hand, is smaller than both Venus and Earth. Venus and Earth are actually pretty close in size. Venus is just a little bit smaller than the Earth. Mars is quite a bit smaller, which means that it has weaker surface gravity. The gravity of the surface of Mars is around 1/3 what we have here on the Earth. So what this means is that it's actually been losing its atmosphere over time. So it loses carbon dioxide, which means we have weaker greenhouse effect, so it actually leads to cooling, and over time, Mars has actually just frozen over because of the loss of its atmosphere. Recently, with the MAVEN mission, this is a few years ago, we actually found that part of this is because of the solar wind. Hey, because Mars is so small, it's cooled off enough, it doesn't have a significant magnetic field, so the solar wind has also been eroding the atmosphere. Okay, again, decreasing the greenhouse effect, causing Mars to cool off and freeze over.